Me and Lily already found out one, okay, that I'm going to go through with you right now, okay, to remember the first quadrant, okay, to remember the first quadrant, you're going to use your left hand, okay, you're going to use your left hand, right, this is your first quadrant, okay, this is 0, 30, 45, 60, and 90, okay? Keep in mind, your denominators are all the same, right? You're always dividing by 2. Now, your numerators, you're always taking the square root. What's the square root of 1? 1, so that's why there's no square root. Give me 1 second. So from here, all right, your left hand, if you drop down 30, how many fingers do I have? How many here? So this is your x, this is your y. Left hand side is x, right hand is your y. Root 3 over 2 and 1/2. Drop your middle finger. How many and how many? Okay. Drop your ring finger. How many? 1 and 3. 1/2 and root 3 over 2. Okay. X, y. Now, if I wanted to find 0 and 90, if I drop my thumb, how many are here? What's the square root of 4? 2 over 2. Okay. If you drop your 90, this is 0, and I need help with it because I can't do it. Square root of 4. 2 over 2. And that's that. I see. Yeah. Well, it doesn't, I need help with it. Okay. So that's one way to do the hand trick. Okay. That's one way to do the hand trick to remember quadrant 1. Okay. To remember quadrant 1, which will help you fill out the rest. Okay. There's another trick too in terms of, and this might help you out in term with the fourth quadrant. Looking at the pattern, just look at your x values right now, and we're skipping over 0, 90, 180, and 270. Okay. 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3 is another way. Okay, so it might help with quadrant 4. Correct. Your negatives you just have to know based off the quadrant. Okay, so 3, 2, 1, 1, 2, 3, 3, 2, 1, 1, 2, 3. Some might like to use the y values instead, but x is always first. Okay, so on your sheet that you have with you, okay, that I just handed out, we are going to add a few things. Okay, so at the bottom, or you could use your unit circle to kind of help this. Right, I'm going to do it on a separate sheet of paper or a separate slide. Okay, so in quadrant 1, what is the deal in terms of x and y? Both positive. Okay, so we are using the word all, okay, in quadrant 1 because sine, cosine, and tangent are all going to be positive. Okay, in quadrant 1, sine, cosine, and tangent are all going to be positive. Okay, when we move on to quadrant 2, what's the deal in terms of x and y? Negative x and y. So we're going to use the word students. Okay. So in quadrant 2, since y is positive, your sine is positive, but cosine and tangent are both negative. Okay. The S is for sine, positive. Okay, let's just finish. It's just, you're going to see in a second. Let's just finish. Okay, quadrant 3, what's the deal in terms of x and y? Both negative. going to use the word take, okay? Because tangent is positive, sine and cosine are both negative. Oh, thank you. Thank you. What's sine and cosine? X and y are both negative, right? To find tangent, which we're going to get to today, is y over x. So that's negative over a negative. Yep. Okay. And the last one is quadrant 4. X is positive, y is negative. Okay. Where cosine is positive, sine and tangent are negative. Okay. So, like we talked about, we're starting to make connections, and we're going to make even more connections today, especially with the sine and cosine and tangent. Okay, that's going to mean more when we go through this shortly. Yeah. And you're going to actually see that right now. Okay, so the reason I wanted you guys to fill this out right now, to kind of get an idea in, do you see, looking at what we have written, do you see any similarities in terms of x and y and so sine, cosine, tangent? Any similarities? Yeah, love. Excellent. Okay, so cosine is positive, but also your x is positive. Okay, cosine is negative, your x is negative. Okay, you have a negative x, and same with your cosine. So cosine and x are the same. They mean the same. So therefore, sine and what mean the same? Y. Okay? So if you look, sine is positive, our y is positive. Sine is negative, our y is negative. Sine is negative, our y is negative. Okay? Tan is, we're going to talk about it right now. Okay? So if you turn to, I forget what page this is. In your notes. 6. Thank you. Okay, page 6 of your notes. You're going to see the connection between SOHCAHTOA and X and Y. Okay. So we have used for right triangles, as you guys are finding your notes, we have used for right triangles SOHCAHTOA. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. Okay? So you could keep the unit circles that we filled out, the warm-up, next to you. Okay? And also have your notes on your desk because you're going to be doing both. All right? So the side opposite, okay, so I want you to visually think this. The side opposite from any central angle. So from the center, and we draw an angle out, the side opposite, also looking at the height, would be what in terms of x and y? Yeah, it would be your y value. Okay, so opposite and the height are some keywords there. Yeah. Do you want one right now, or do you want to go get it? Okay. What? Visually? Okay. Okay. So visually, if I did a central angle this way, that would be your opposite and your height. Okay? So the central angle is you're creating an angle from the origin and going out. Okay? So opposite, excuse me, opposite and the height represent y. So then the side adjacent from any central angle and the width or the horizontal length would be what? X, right? So adjacent and the width. So we have this guy there, all right? Then the hypotenuse of the triangles in the unit circle now represent the radius, okay? So instead of C, we're using R, okay? So now we're going to take our knowledge of SOHCAHTOA and now look at X, Y, and R, okay? So instead of opposite over hypotenuse, what would that be in terms of X, Y, and R? Yeah, Josh. Good, Y over R. How about cosine? Jason? X over R. And now tangent. Y over X. That's why in quadrant 3, both X and Y are negative and tangent is positive because Y over X. Okay? So, we're going to see the similarities between our basic right triangle trig and then the unit circle, okay, to find exact values. So here's our right triangle. Here's 30 degrees. What would be the cosine of 30? Go ahead, Josh.
Would it be root 3 over 2?
Correct, which would just be root 3 over 2, right? Because it's adjacent over hypotenuse. What would be the sine of 30? 1/2. Good. Thank you, Ethan. Which is opposite over hypotenuse. Okay? Yep. Everyone okay? Then if we move to 60 degrees, which isn't labeled. So if we move to 60 degrees, what would the cosine be? Jason? 1/2. What would the sine be? Good. Root 3 over 2. Okay? So we know that based on our knowledge of SOHCAHTOA. So now we're removing the side lengths and we created our point. Okay, we created our point on the circle. So now what would be the cosine of 30 is X over R. Remember, your radius is 1. So what is the cosine of 30 looking at the unit circle? Root 3 over 2. Because that's our X value. What is the sine of 30? Sine, remember, 1/2. Okay, so in terms of unit circle, cosine is our X, sine is our Y. Okay, so 60 degrees is not labeled on our unit circle right here, so we're going to label it. Okay, if this is 60, what is my coordinate point then? Look at your unit circle and tell me what 60 degrees is. Liv? 60. Yep. Good. Okay, remember 60? Okay. What would be the cosine of 60? Using my unit circle. Go ahead, love. 1/2. Good. What would be the sine of 60? Go ahead. 3 over 2. Okay. Which should be exactly the same as what we got for our SOHCAHTOA. Okay. So when you're finding exact values for the unit circle, okay, remember that your x values are cosine, your y values are sine, okay? Well, what about tangent, okay? So if I use SOHCAHTOA or my point given, I know 30 degrees is root 3 over 2 and 1/2, okay? Or if I look at my right triangle. So tangent is what in terms of SOHCAHTOA? Opposite over adjacent. So what would that look like? I know it's going to look very weird, but what would that look like? Yeah, Kat. Good. So it's not looking too pretty, right? 1/2 over root 3 over 2. Doesn't look too nice, right? Well, what can we do? We can't have that as an answer. Yeah. Not the 1/2. The 2's we could cancel out. Okay? So the 2's, so we have 1 over root 3, but can we have a radical in the denominator? Good. Okay? So the tangent of 30 is root 3 over 3. Y over x, or sine over cosine. Okay? So now the tangent of 60, here's my point. What would that look like to start up? Jason? How would it look before I simplify?
Oh, root 3 divided by 2 divided by 100.
Good. So then, same thing. 2's could cancel. I'm left with root 3. Okay? So, sine, y values, cosine, x values, tangent, y over x. Okay? Makes sense? Okay? Getting used to exact values can be a little tricky, okay? If you don't really fully understand the unit circle yet, okay? But it will all start to come together. If you turn the page, we're going to start with the first 3, and then you guys are going to work with a partner for the rest, okay? Then we will get into other stuff. So, sine of 45. Using your unit circle, what is the sine of 45? So the sine would be what? Just root 2 over 2, right? It's the y value. What is the cosine of 45? Root 2 over 2. What would be the tangent of 45? Yeah. Okay, so root 2 over 2 over root 2 over 2. Careful. It would be 1. What? If we were using SOHCAHTOA, yeah. But the tangent would be 1. Yep.
But would it be multiplying the square root of 2 to bring it over and be the square root of 4?
What's the square root of 4? 2 over 2.
Because the radical cancels out.
Okay. So your denominator cancels, right? So say if you wanted to rationalize, okay, and you had root 2, I would have root 4 over 2. Yep, so what's the square root of 4? Okay, it's okay, great question. Okay, so the sine of 45 was the y value, even though they're the same, okay, when we get into, I want you to remember, the sine is our y, cosine is our x, and tangent is y over x. Okay, so I'm going to give you 5 minutes to work with a partner D through J, okay? D through J. Try your best, okay? Bounce each other's ideas off of each other. 5 minutes. Go. All right, so the sine of 150, Lily B. What do we got? 1/2. Good. Okay. Cosine of 150, Amelia. Positive or negative? Negative. Good. Awesome. Good job. All right. Tangent of 330. James, do you have that one? Careful. Careful, careful. Tangent is y over x. So 330, that point. It's okay. Good. Sorry. Yeah. Negative root 3 over 3. Because the tangent of 330 is positive root 3 over 2. Negative 1/2. Yep. What, honey? Yes. Yeah. So the signs are going to be whatever it is. You're not going to change anything. Right? The sine of 90, Jason. 1. Okay, the sine of 135, Liv. Good, root 2 over 2. Cosine of 270, Alina. Careful, cosine of 270. Cosines, what values, x or y? X. 0, good. Tangent of 180, Ethan. 0. Okay, so my question to you then. So tangent of 180 and tangent of 360 is 0. Yeah, Alina. Okay, so here's the point for 330. Okay, here's the point for 330, right? And it's y over x. So it's negative 1/2 over root 3 over 2, right? So negative 1/2 over root 3 over 2. Okay, your 2's cancel, and then negative 1 over root 3, and then you rationalize. Okay? So if tangent of 180 is 0 and tangent of 360 is 0, what happens to tangent at 90 and 270? Yeah, Jason? Correct. So tangent at 90 and 270 is undefined because it's 1 over 0 and then negative 1 over 0. Can't divide by 0. Okay, so one thing that we are seeing that using the unit circle, a lot of these exact values are going to be roughly the same. Their signs just might be different. Okay, so, and the reason we did colors on our unit circle is we are pointing out reference angles. Okay, so those with the same color, okay, are going to have the same coordinate points, however their sign might be different depending on where it is. Okay, this is important that your reference angle is always between 0 and 90. Your reference angle is always between 0 and 90. It always refers back to quadrant 1. Doesn't matter where it is within the unit circle, it refers back to quadrant 1. So, and this goes back to your point for quadrant 4. You're always looking at the closest x-axis. So it's either 180 or 360 you're looking at. okay? So to find your reference angles, 2 and 3 are referring to 180. Quadrant 4, 360. Okay? Yeah. Oh. Right. So if I wanted to state 3 angles that had a reference angle of 60, okay? So that have a reference angle of 60, we're going to use our unit circle. What would be 1? 120. Okay, so in quadrant 2, since I have the closest x-axis will be 180, 180 minus 60 gives us 120, which is the same colors they had, right? Okay, so one way to find it, even if it's not within the unit circle, you take 180 minus the reference angle they gave you, okay, to find the angle. Now, in quadrant 3, which degree has the reference angle? Yeah, 240. So we would do 180 plus 60 to get 240. Closest x-axis. Yep. Okay. Then lastly, in quadrant 4, what would be my reference angle? I mean, what would be my angle? Sorry. Yeah, 300. So the closest x-axis, would that be still 180? No. 360 minus 60 gives us 300. Okay. X-axis is only using 180 and 360. Yeah.
So does there always have to be a 60?
Would you-
Subtracting 60, adding 60.
Yeah. So here, because we're given the reference angle of 60, that could change though. So it's not all the time. Like in this second one, state 3 angles that have a 45-degree reference angle. Okay? So looking at your unit circle or using some math, okay, what would be the first degree that has a reference angle of 45 in quadrant 2? 135. So if I needed to, 180 minus 45. How about the next one in quadrant 3? 225. So 180 plus 45. And last but not least, quadrant 4 would be what? 315. Good. Okay. So that's when it's giving you the reference angle and you have to find those angles. Okay. Now, on the flip side, they're giving you the degree and have to state the reference angle. So this is going to help those of you that were having some issues with quadrant 4. This will help, okay? To get you in that mindset, you're only using the x-axis, okay? So 182 falls in what quadrant? The third, okay? Since it falls in the third, okay, we would take 182 minus 180 to find a reference angle of what? Come back. Q. Okay, 2 degrees. Okay. Now, if I wanted to see for 220, what quadrant does that fall into? The third. So we're still doing the same thing. 220 minus 180. What do I get? 40. Good. $315 is in what quadrant? Fourth. Am I still using 180 or 360? 360 minus 315. What do I got? Okay. And last, fourth quadrant. 654. Good. Okay, so we've seen a lot of quadrant 3 and 4, right? So I want you either above or somewhere, wherever you can find room in this vicinity. I want you to add 100. What quadrant does that fall in? 2. Okay, so that's in quadrant 2. So the closest x-axis is 180, right? So 180 minus 100 is 80. So my reference angle would be 80 degrees, okay? So that just shows you quadrant 2, since we've seen a lot of 3 and 4. Yep. Yes. Okay. So in quadrant 2, and you could add this to your little, the one we did at the beginning of class if you wanted to. This guy here. Here, in quadrant 2, to find your reference angle, in quadrant 2, you would take 180 minus the given angle. Okay? In quadrant 3, to find your reference angle, it's the given angle minus 180. Okay, so like 230, 225. Okay? In quadrant 4, to find your reference angle, it's 360 minus the given angle. Yeah. Go. Yep. You could do, well, there you would get the same thing. Okay. But 270, and I'm glad you brought, great point. 0, 90, 180, 270, and 360 are quadrantal angles. So they really don't belong in the quadrants. However, 270, the reference angle would be 90. 180, the reference angle would be 0, actually. And 360, it would be 0. Okay, so those you really won't see in terms of reference angles. Okay, yeah. Yeah. Okay. Any other question? Yes, always. Okay, so again, this also might help to change the mindset too, that you're looking at 180 and 360 only. Okay? All right, so the last two things for today is you are given a point. Okay? You're given a point, 8, -6. Okay? It's a point on the terminal side. So remember, you are always starting at that 0 position. Okay? You're always starting there. Okay? And it goes around clockwise, counterclockwise. All right? We want to find the exact value. So 8, -6, the first place you want to start is, what quadrant is that in? Careful. 8, -6. The fourth, why? Because the y is negative. So this is in quadrant 4 because x is positive, y is negative. Okay? So what it looks like in quadrant 4, 8, -6 okay. I'm drawing a triangle, God bless you, in quadrant 4. Okay? We're creating a central angle, which is right at the center. Okay? We have our right triangle here. Now, how would I label this triangle? Which is going to be 8, which is going to be -6? How can I label it? Josh? Yeah. Okay, so in terms of 8, -6, which one would it be?
That one would be
Good, good. -6 because it's the y value, and it's the vertical, and it's also negative. Okay? The 8 is going to be on top. It's your horizontal. It's your x-axis. Okay? So now, what do I need to find before I'm able to find those trig ratios? The hypotenuse, which is always going to be positive. In order to find the hypotenuse, what do I need to do? Perfect. Yep, always. No, not in this case. No, anytime you're finding, and great question, anytime you're finding the C, you don't need to include the positive and negative because it's always going to be positive. Yeah. Yes. It's always a positive hypotenuse. Always. No matter what. Because your side lengths are either going to be positive or negative. Okay? Alright, so 8 squared. C squared. So James already told us that the hypotenuse is 10. Okay? So when you're doing the trig ratios for now, you guys, I know we like to reduce. You can reduce, but just leave it so you have, or reduce next to it so you could always refer back to where you got those answers. Okay? So the sine of theta would be what? Use the values given. -6/10. Opposite over hypotenuse. What would be the cosine? 8/10. Adjacent over hypotenuse. Go ahead. Like I said before, you can, but I want you to keep those as is to refer back to. Good. -6/8. And I know in some we have simplified, others we just left. Just to always go back to and refer. You can simplify right next to it, though. It doesn't matter. Yeah. Okay. So now in example 2, what quadrant is that in? -2, -1. Well, 3. Yep, good. Excellent. It would be in the third quadrant. So you would draw your triangle. It always comes out, and I'll show you above what it looks like. Okay? It's always coming out from that center. So how am I labeling my side lengths? The center. The center. Always from here. Yeah. Go ahead. -2, good. And then? Perfect. Okay. -2 is your horizontal distance, your x-axis. Okay? And your y is always your drop down and your vertical. Yeah.
So it's whatever it's parallel with, like the line that you're drawing, whichever axis is parallel with is the
X-axis. Yes. Okay. Not with the point given. You might be given something like that, which we'll talk about in a second. Okay? So what I want you to do right now is find your hypotenuse, then find your sine, your cosine, and tangent. Okay? So find your hypotenuse, which is always positive, then find your sine, cosine, and tangent. No, it's always from the center.
Oh, it's always from the
Yep.
I like the line.
Because it's theta. That's what you're supposed to do. Okay. All right, so I'm just going to write this up here so you guys could refer back to. Yes, you can. You can have a radical as a hypotenuse. What do you mean? No. Like what we did at the beginning. No.
For right angles and stuff, there is a vertical determinant. That's what we would do.
Rationalize. Yeah. Yep. So as you guys are finishing up, just so you could see what each quadrant looks like when you're drawing these central angles, okay? In quadrant 1, you're always going from the center out and then down. You drop a perpendicular line, okay? Quadrant 2, go out, then down, because you always want that angle to come from the center. Okay, so you might want to jot that down due to the fact I've seen angles in so many different ways, okay, that you always want to go out, kind of creating your bow tie, right? Okay, so you're always creating your central angle. So create a right triangle when plotting a point. So if you were given an XY plane and you graphed 8, -6, you would plot that point and draw your hypotenuse and your line. All right. So what did we get for our hypotenuse? √5. Good. Okay. So what is the sine of theta? Go ahead, Mia. Excellent. -√5/5. You have to rationalize these things. Okay. How about the cosine? Go ahead, James. Good. -2√5. All right. And then tangent. Go ahead, Devin. Careful. Be careful. 1/2 is correct, but would it be negative or positive? Positive, because it's a negative over a negative. Okay? That's okay. Cancels out the negatives. And since we're in quadrant 3, this goes back to what we just did, right? The x and y are both negative, but y over x gives you the positive. Okay? Lil, did you have a question? All right. So, now, this is where it can be just a little tricky. What is the difference now? What are we given? No, careful. Not in this one. Tangent, right? So, yeah. So tangent of theta is 5/12, which is positive, okay? The sine, however, is less than 0. So what does that mean? Would it be positive or negative? Sine. Negative. Okay. So my question to you is, when it's less than 0, it means negative. Okay. So where is tangent positive? What quadrants is tangent positive? 1, 1 and 3, tangent is positive, right? Okay. Out of those two quadrants, where is sine negative? Out of these two? 3, right? So that's where this triangle is going to be, in quadrant 3. So you first determine where tangent is positive, which is quadrant 1 and quadrant 3. Sine is negative in quadrant 3 and quadrant 4. But the one they have in common is quadrant 3. So that's where we're going to build our triangle. Okay? So in quadrant 3, we're going to draw it the same way as we did above. Now, tangent is what in terms of SOHCAHTOA? Opposite over adjacent. In terms of x and y, what is it? Y over x. Awesome. Okay. So how would I label my triangle knowing this is my central angle here? How would I label it? Go ahead, Jason. Okay. Do I have to include anything here? No, we have to find that. But first, why? Perfect. You have to put the negatives here because a negative over a negative is a what? Positive. So since we're in quadrant 3, good Liv, negative and negative, you need both negatives. Correct. Yeah, you're trying, it's like putting a puzzle together, right? So now that you know your two side lengths, you have to find your hypotenuse, which is always going to be positive. Okay? So go ahead and find your hypotenuse. Then find sine, God bless you, sine of theta and cosine of theta. Okay? Give those a try. All right? Correct. So cosine is negative in quadrant 2 and quadrant 3. Tangent is negative in 2 and 4. Huh? It's less than. Okay? So where they have in common is quadrant 2. Okay? So now, cosine is what in terms of SOHCAHTOA? X over R, right? But it was adjacent over hypotenuse, right? Okay? So, remember, your hypotenuse is always positive. So how would I label this triangle? Yeah. Perfect. Excellent. Good job. Okay, the hypotenuse is always positive, so that takes the 5. The x takes the negative with it. Okay, so now we have to find this side length. Yeah. Yeah, it's a 3, 4, 5 triangle. So if you did Pythagorean theorem, just if you didn't recognize it's a 3, 4, 5 triangle. Um, but I just want to show you something. Okay, even though we are correct, okay, when we take the square root, okay, this is the case where you might have to include plus or minus because you should have two values, right? Positive 4 and negative 4. However, we're in the second quadrant. So should that 4 be positive or negative? Positive, because the y value is positive. So that's why we take the positive 4. Yeah.
What other patterns are there to look out for?
It's really just 3, 4, 5, I think. Oh, 5, 12, 13. 5, 12. Yeah, multiples, so 6, 8, 10. We saw that as well, and you could keep going with that, but 5, 12, 13, I think is another one, which we just did. Okay. Yeah.
This is somewhat unrelated, but if a right triangle and the two legs were one, or the hypotenuse would still be one, even though it looks longer than the two legs.
No, it would be square root of 2.
Oh, because you're adding them.
Yep. Okay. So, good. Like the thinking, though. Why not, right? And this is it. So, oops, we already found cosine. What would be the sine of theta? Of 4 over 5. And what would be the tangent? Go ahead, Jason. Yep. The whole thing becomes negative.
Yeah.
What?
Not negative 4.
Yeah.
Fraction.
The whole fraction becomes negative, yeah. Okay, which proves this point too. Okay? Yeah. Okay, so your practice, okay, is the 6.2 practice, okay, which is pages 9 through 12, okay? Pages 9 through 12, all right? 1 through 23. So this first page is the exact values, okay? 1 through 12 is the exact values, what we did prior, okay? 13 through 15 are, you're given a point. You have to find the angle, okay? And that's why it wasn't filled in for sine of whatever angle you're because then that would give you the answer, okay? So you find the angle of that given point, okay, on the unit circle, okay? Right. It's not like theta. Yeah. So then 25, hold on one second. 25 is a chart, which can be a challenge, but I want you to try. You're filling in the pieces. Okay, then it's filling out the unit circle. Yes. Yep. Then 25. And then the unit circle on page 12. Okay? Yeah.
I should fill my unit circle.
Let me just have them write that down. No, 24 you guys already did, actually.